Hello, today we're going through sequences in GCSE. So in a GCSE test you usually have 4 different kinds of sequences, and those are geometric, Fibonacci sequence, linear sequences and quadratic sequences. So I'm going to start with geometric sequences. So I'll start with an example straight away. So we have a sequence of numbers 2, 4, 8, 16 and 32. So in this sequence you may see a trend going on. If you don't, that's fine right now, you'll learn to identify it. So the trend that goes on is that between each term you times by 2. You see this? 2 times 2 is 4, 4 times 2 is 8, etc. So this times 2 is known as the common ratio. So you can express the rule of a geometric sequence using the formula A, which is just the term, is equal to the first term times by ratio to the power of n minus 1, n being the number of the term in the sequence. So an example of this is, for this sequence, first term is 2, so I'm going to replace A1 with that. I'm going to times it by the common ratio, which is 2. I'm going to put that to the power of n minus 1. That's how I'd express the rule for this geometric sequence. Okay, so next we're going to look at the Fibonacci sequence. So this is an example of the Fibonacci sequence. So it starts with 0, and then this doesn't quite follow the rule, it's a bit confusing, I don't really understand it, but they just add 1 here at the start to start off. And the rule of the Fibonacci sequence, if you haven't noticed it, is that to find the next term in the sequence, you add these two numbers together. So 0 plus 1 is 1. To find the next number in the sequence, we add 1 plus 1, which is 2. You can see it's accurate. So I'm just going to go through finding some more numbers in this sequence. So to find the number after 8, we just do 5 plus 8, which is 13. It's 13. Now just do it once more. Find the number after 13, do 8 plus 13, which is 21. So that's Fibonacci sequence. So Fibonacci sequence is often used in architecture. It's often known as the golden ratio for area. It's also like naturally in things, so you'll see in a lot of seashells it follows the Fibonacci sequence for some reason. So it's quite good for aesthetics and design. Okay, third we're going to go through linear sequences. So this comes up quite common on your GCSE, and you express the rule using algebra, usually with the nth term. So I have this sequence, minus 2, 1, 4, 7. So you may notice that it goes up in 3s each time. So I'm going to write 3. So this is known as the common difference. So I'm going to take whatever the common difference is, I'm going to write 3n, or any letter, but usually it's n. That's not the end of it. So we have, if we look at what the sequence 3n is, find that it's 3, 6, 9 and 12. So you can see that that is not the same as this, where this sequence also goes up in 3s. Meaning we just have to take away something from this sequence to get down to this sequence. So we can look at, how can we get from 3 to minus 2? We minus 5. So we write minus 5 here. And this is the rule for a linear sequence. And it's different for each one. So if I wanted to find the 5th number in a linear sequence, I'd replace n with 5. So I'd get 3 bracket 5 minus 5, which is equal to 10. So that'd be the next one, and we see that it also goes up in 3. That can be the. And finally we're going to go through quadratic sequences. So I'm going to start with an example. So we have the sequence 2, 7, 14 and 23. So we're going to go at it like a linear sequence by finding the common difference. So 7 minus 2 is 5, 14 minus 7 is 7, and 23 minus 14 is 9. The difference between quadratic and linear sequence is that the first common difference is not equal to each other. So this time we do it again. We find the second common difference. So 7 minus 5 is 2, and 9 minus 7 is 2. So if the second difference is the same, you know that it's a quadratic. So now there's many different methods for finding the equation, but I like to use the algebra method. So we know that the second difference is equal to 2a. The first difference is equal to 3a plus b. And the first number in the sequence is equal to a plus b plus c. So if we start with the second difference, say that 2a is equal to 2. You can find that a is 1. Now we know what a is. 3a, so 3 plus b equals 5, meaning b is 2. And we know a and b, so we can work out c. So a is 1, b is 2, so 3 plus c equals 1, meaning c is minus 1. So now we substitute this into a quadratic equation, which is going to be an squared plus bn plus c. So a is 1, so it's just n squared, b is 2, so it's just 2n, and then c is minus 1. So that is the expression for this quadratic sequence. Okay, so now you may be wondering where I got those equations from. So now I'm going to prove them. So we have 1, 2, 3. These are the n values. So they're representing the position of the term in the sequence. So we're going to substitute in 1 into this equation as n. So 1 equals n, so we have a, and then b plus c as the first term. Then if we substitute 2 to this expression, we have 4a plus 2b plus c. And then if we substitute 3 in, we get 9a plus 3b plus c. Now we're going to do what we normally do for a quadratic sequence. We're going to find the first difference between these algebraic expressions. So the two c's cancel out, so there's no c here. We have 4a minus a, which is 3a, and we have 2b minus b, so that's plus b. And then you'll find that if we do it here, 9a minus 4a is 5a, 3b minus 2b is plus b, and the c's cancel out. So then, following a quadratic sequence, we find the second difference. So 5a minus 3a is 2a, and the b's cancel out. So if you'll see, these are the same equations I used earlier. So we know that the first term is always equal to a plus b plus c, and the first common difference is equal to 3a plus b, and the second difference is always equal to 2a. Okay, well done for getting to the end of the video. So we have a special announcement. We're nearing 50 subscribers. Well done, guys.
Yay!
So we were thinking of having a 50 subscriber special.
Yeah, of course. 50 subscriber special.
But we need the support from you guys.
Of course, and the
on
ideas.
Suggestions.
Yep.
We were thinking maybe mukbang, special ASMR.
Yeah, ASMR. 5 times 2 goes 10.
Anything else?
Any ideas you have for future subscribers, please let us know. But don't say kill yourself, because we don't want that to happen.
Yeah.
But, anything but that. So, yeah, please give us suggestions. We need to know what to do. Anyway, thank you guys. Like and subscribe.